Hi, this is Miss Linda, and this is Honors Bio Unit A review. Say hi. Hi. And we have some AP biologists in the room. You can say hi too. Hi. And we're getting ready for our final. So this is the final unit of the year, Unit 8, and it was all about application. So we did stress, biotech, sustainability, and biomimicry. And again, I want to encourage you to go to your calendars. Are all located on the website, so you can go there and review them and make sure you have your big ticket items done as well. Okay, so the first one, stress. You had a hyperdoc just on stress, and it was more for you to kind of experience, not stress, but experience a lot of different things, learning about how it tied together our different systems. And we focused on the negative aspects of stress quite a bit so we could see how it could affect our health, specifically if you would get sick, if we could pass that information on to our children. So just what I want you to have for a takeaway for the stress hyperdoc is make sure you understand, are there any positive impacts of stress in your life? Is stress ever good? And then is stress ever unhealthy? Those are just the takeaways from that you would want. Okay, the second topic that we had was biotechnology, and in a previous review we did in Unit 6, we actually went over all the content of Chapter 20, the second half of Chapter 24. So if you need to review the content, I would go and watch the Unit 6 review, Chapter 24, and we did it in its entirety. My computer is making freak out things. Then following up with the content on it, we did a lab on it, and that was our Amgen lab. So before I even start talking about the Amgen lab, and AP biologists, this would apply to you as well, is think about what were the main steps, not the learning day where you learn the tools, but what were the main steps of the lab, the key components of the lab. Why don't you discuss those for just a moment, please?
In order. Cutting, taping, gel electrophoresis.
All right, let's try to identify those steps together. The very first step starts with a D. What would that be? Digestion. That was the name of that lab, was digestion. What did you do during the digestion portion? You cut your plasmids. What did you use to cut your plasmids? Yes, restriction enzymes. You want to remember that restriction enzymes cut at a specific series of bases called a recognition sequence and create, if they're helpful to us in genetic engineering, they would make what? Sticky ends. Good, so we can mix and match our DNA. What was our next step? Not gel electrophoresis. Yes, but what did we have to do before we actually did the ligation? Started with an I. AP, you're in the room. Thank you. Inactivation and ligation. What was the significance of inactivation? Yes, turn off those restriction enzymes, denature them. Because if we had just ligated, and what do you use to ligate? What enzyme? Yes, ligase. And what did we use to inactivate? Heat. Remember the hot water? So we would inactivate the restriction enzymes and then ligate the new combinations. Then we did what? Yeah. Now, gel electrophoresis was not actually a necessary component of the lab. You don't have to do it to transform things. We did it to check our work so far of our first two steps. That's why we did gel electrophoresis. What does gel electrophoresis do? Separates DNA according to size. Good. Okay, what was the fourth step we did? Transformation. And then to check our transformation to see if we had actually done it, what did we do after we had transformed them? Yes, put them on plates. Plated them out to see how they would grow. So we were given two plasmids, pecan and piara. Within pecan, something was silent. What was silent in pecan? RFP was silent. There was no way to turn that gene on. So what we wanted to do is cut it out of RFP and sneak it into piara by cutting open piara. Now, once it's in there, we would have a way to turn it on. Our way to turn it on is by feeding bacteria that were transformed with this plasmid, feeding them what? Arabinose. And when they turn on their arabinose gene, they would turn on their RFP gene. That was our hope. Okay? Apper's not too loud. So here we can see we had 4 tubes, A plus, K plus. What were the other 2 tubes that aren't shown right here? A minus and K minus. What were those? The control, the uncut plasmids, so we could use them as comparison. All right? And on ligation day, I gave you ligase. I had put ligase in there for you. So you just needed to add water, buffer, and a little bit out of your K plus and A plus after you had done the inactivation step, right? You had to do the inactivation step first. All right? Then we did, I shouldn't have put, we were trying to make piara, and we could have made a lot of plasmids, but we were trying to make piara R, which had the RFP gene next to the arabinose gene. So then we wanted to check, did we cut, did we tape, is it possible that we even could have made the piara? So that's why we did gel electrophoresis. We put marker DNA, known size pieces of DNA to be used as a what? Comparison, good. And then we put in K minus and K plus samples so we could see, does it look different, the cut from the uncut? Same thing, A plus, A minus, and then you put from your Lig tube. Because you should have whole plasmids in there that move very, what? Slowly, okay? So we checked to see, did we cut in the right place by using the marker, and did we ligate? All right, then once we had verified that we had done that, we did our transformation day. So you had 2 tubes of bacteria. One of the tubes, you didn't add anything to it. Why did we have that? For our control. The other tube, what did you add to it? What did you add to your other one? You added E. coli in both tubes. Yeah, out of your Lig tube, your plasmids that you made. So you added Lig to that, and then that would be your only bacteria that could be transformed. And there was a series, you had a heat shock, which was really important. What was the heat shock doing in the lab? Not denaturing. Heat shock wasn't denaturing. It was changing the pressure to force the plasmid into the E. coli. That was a critical step. Okay, not so loud, guys. And then we plated out. Why did we have a luria broth plate? What was the purpose of this luria broth plate? Yes, are your bacteria even alive? That is the whole point. Because we used antibiotics on the remaining plates, and antibiotics kill living things. So we needed to say, hey, do we even have living bacteria to start out with? So that's why you put your P plus and your P minus on there. Are they alive? Your second plate had ampicillin mixed in it, and you put P minus and P plus on that. What was the purpose of that plate? Yes, to see if they're antibiotic resistance, but to see if you could do what procedure, if you could do what to them. Appers, you're in the room. Why did we have an ampicillin plate? If we could do transformation. That was the point of that plate. Can we transform bacteria? Because if we could transform them, then we would expect to see bacteria growing on the P plus side of the plate and not the P minus plate, right? Because these we didn't give them any plasmid, these we did. So could we give them antibiotic resistance? The last plate, we just put P plus on it that had the ampicillin, so only transformed bacteria could survive there. And then if they had the RFP gene in the right place, the arabinose sugar would turn on that plasmid. Okay? Can you check with your neighbor bio buddy and see what of that do you need to review a little bit more, or do you feel comfortable? All right, then our last chapter of, is there anything you want to ask me content-wise on that? Did I go too fast? Okay, the last thing we needed to talk about, there were several different topics in this last chapter that we want to review, but we just learned this, so this should be pretty good, okay? But this is basically man's impact on the environment, how we destroy it. We talked about how we destroy where we live, the earth, how we decrease numbers through extinction, and why we would want to maintain the biodiversity that we have on this planet, and we ended with maybe some strategies for that. So on this chapter, we talked about renewable versus non-renewable, right? And I think you feel comfortable with that, right? Renewable resources would be things like what? Wind, what else? Solar, good, okay? Then non-renewable resources, oh, there's renewable. Did I show you non-renewable? Yeah. Okay, good. All right, and then, so tall. Then we started looking at all the ways we are destroying our resources. So we went into a whole thing about, land, beach erosion, pollution on our land, deforestation. We talked about loss of water or access to water. We talked about how most of the crops we actually grow actually go not to feed us, but actually to feed what? Cows, right. Okay, we talked about poor farming practices, and what I would do is just look through and review those, because I don't think those are difficult topics to review. But we talked about the decrease in all of our resources. We talked about overfishing. Okay, then we went into, okay, this is how man screws up the land. How does it screw up the living organisms? How does it decrease biodiversity? And that was through extinction. And what you want to be sure and clear about are examples of the different forms of extinction and know which ones are the biggest forms of extinction. Remember, when an animal goes extinct, it could be more than one of these items making them extinct. But the number one cause of extinction is habitat loss. And number two? Exotic species. Number three?
Pollution.
And number four? Overexploitation. That's like overfishing. And number five was disease. So habitat loss, I think you understand that pretty well. When we talked about exotic species, remember these are non-native to a location. They were either brought there accidentally or on purpose, but they are living currently in an area that they did not involve in. And so they don't necessarily have a natural predator. They might outcompete the other plants because they didn't have to learn how to compete within that paradigm. They were brought from somewhere else. And so we looked at the decimation of food webs. We've looked at where man has stepped in to try to increase numbers, and we end up making it worse. Remember Operation, or did I do this in this Operation Cat Drop? Yeah, Operation Cat Drop, right, okay. We talked about how islands are especially susceptible, right? Because and we looked at examples with birds and how native birds are getting decimated. Do you remember what was moved in? Mongooses, right? And they were brought in to get rid of the rats, but they ended up killing off the native birds. Okay, pollution is a contributor, and we looked at different forms of pollution. That was of water, sorry. Overexploitation, and we talked about, on pollution, there was acid rain. Do you remember all the different ones of pollution? Do you need me to review them? Okay, right. We talked about overexploitation, where you fish things and like to extinction, or we talked about harvesting cacti or harvesting fish near coral reefs. And when they are decimated, then they become more valuable. People want them even more, and then it goes in this endless vortex of extinction. And then the fifth cause was disease. All right, so we learned how does man screw up the land, how does man decrease biodiversity, and then we talked about, well, what's the counter argument to that? Why would I care about these different, or why do I care about maintaining biodiversity? and we talked about direct and indirect values. I will ask you about which ones are direct and which ones are indirect. I think you'd be able to figure out the indirect ones, but do you know the direct values? There were 3. Discuss with your bio buddy. See if you can remember your direct values. Did you come up with medicinal value? Yeah, so you have medicinal value, and we talked about agricultural value, and we talked about consumptive value, right? Remember all of that? Okay, so then we talked about indirect values, things that you don't necessarily see. So how they're involved in, let's say, the different cycles, the water cycle, the carbon cycle. We talked about climate. We talked about, what else? Do you remember some of the indirect values instead of me saying them? We talked about how forests are like sponges for water. Do you remember that? Okay, so just review your indirects, and then we talked about having a sustainable society would be able to maintain our environment and not decimate it, right? So we talked about strategies for that as well, because right now, currently, we're altering land, using non-renewable energy, taking our grain to feed animals, polluting our water supply, focusing on non-renewable energy to power our homes and cities, and we're causing a lot of pollution. So we want to try to do whatever we can to avoid that, which leads us into our last topic, and that is on biomimicry, which the idea behind that is, let's look to see how other animals who have survived on this planet a lot longer than we have, who need the same things. They need food, they need shelter, right? They need to have things that they need to consume, but they manage to do it without decimating the planet like we do through heat, beat, and treat systems. So maybe we need to explore some of the ways in which they have adapted to the environment and employ some of those for ourselves. And we looked at types of paint, we looked about water, we looked about, last year we looked at structure of homes. And so for that last chapter, you want to be familiar with what biomimicry is and the advantages of adopting some things of other organisms, like in our treatment of carbon dioxide, etc. Okay, and then that's the year. Good job. Yay! Does anybody have any other questions you want to ask me? Okay, have a piece of toast, study for your final. I'm sure you will do an awesome job.